This is the Lockpicking Lawyer, and what I have for you today are two U.S. Postal Service registered mail counter locks. These locks have gone through a lot of redesigns over the years. I have what I believe to be the two most recent designs. And they're not so much designed to provide security as much as to act as a reusable tamper seal for registered mail bags. And to do that, they have two features. The first is every lock has a unique serial number on it. You can see them right there. And also, each of these locks has a counter on the side, and that counter increases by 1 every time you open the lock. So it doesn't matter if you can pick them open because it will show on the lock. So the theory is if the mailbag starts in one location with a certain serial number lock and the counter at a certain number, and it arrives at the next location with those numbers intact, presumably the bag hasn't been tampered with. Now, I've seen a lot of disinformation about these locks on the internet. Some people saying they are lever locks, others saying they're wafer locks or warded locks, but all they are standard pin tumbler locks. Each of these has 3 pins, and they are set way in the back of the keyway. I'm operating at almost the full length of the pick to get the deepest pin. But we're going to pick these guys open, and then what I'm going to do is show you 2 of them that I've taken apart so you can see the insides. Now, you can't take these apart without destroying them, or it would really defeat the purpose of being a tamper seal. They each have, let's see, it looks like a peened over piece of brass here holding it together, and in fact 3 of them, 1, 2, 3 on this lock. So once you drill them out, the bottom slides off and you can see the entire mechanism. But first, let's pick these guys open. And then I can show you what's inside, and you can see the significant redesign on the inside. This one being a whole lot cheaper than the older ones. Okay, let's get those 3 pins. 1 is springy. Click out a 2. Click out a 3, and I think we're moving. And as I start to turn this lock, I want you to notice a couple things. First, listen for a click. Okay, we have a click right there. The number hasn't quite moved. It was on 89 before. But what you can see is we've passed the point of no return. As this shackle rotates, there is a ratchet mechanism in there that makes it so you can't turn it backwards. Okay, so let's keep rotating it and watch the numbers. Okay, we went up to 90. And more clicks as the ratchet mechanism keeps going. And we're back in the locked position again. And, well, you can certainly see it change, but I guess the numbers don't change quite as well as we'd like them to. Okay, let's do the older style lock now. Again, 3 pins in there. Okay. Click out a 1, another click, 2, springy I think, nothing on 3. Okay, another click out a 1, nothing on 2, 3's binding now, couple clicks, maybe 1 more. Okay, it's starting to rotate now. And again, listen for the click as the ratchet mechanism works. Okay, we've passed the point of no return, and that's before the shackle fully opens, so that's a good thing. And we are on 778, and we should turn over to 779 right there. And again, the ratchet mechanism keeps going throughout the process, so you can't turn it back. Okay, let's take a look at what's inside of these locks now. I have 2 of them here that I have drilled out the peened over pieces of brass. On the first lock, I'll take the newer one apart first. There is only one place you have to drill out. That's on the very bottom. And I've reset the numbers. So once I have this apart, you can see what happens when it reaches the end of its line. And I guess my first thought when I saw these was, okay, you just get a key, you attach it to a drill, you turn it 10,000 times, and you can defeat the mechanism. But no, these locks actually can't be used after they reach the end of their process. So, I opened this the wrong way, and I dropped out a couple of the pins. So let me put these over here. Okay, let's get the rest of this out. Okay, I dropped one spring. I think that was from chamber 3. And let me drop everything out. First thing I'm going to drop out is the pin from this hole right here. And that's actually the ratchet mechanism. I'm going to put that over in chamber number 5. And we've already lost everything out of number 1. So here's everything from number 2. And from number 3 now. So normal pins, nothing special there. Now that I have these pins out, let me show you how this operates. I can just turn the shackle and you can see these numbers. Let's see, we would turn them, I think this way. We go to 9,996, 97, 98, 99, and then the lock just jams up. It can no longer be opened after the 9,999th time. If you really force it, you can probably jam up this nylon mechanism, but let me actually show you what's stopping it. On each of these wheels, I'll just take this apart one by one, we have this little nylon ratchet. I'll give you close-ups of these. But the key feature here is this one that's shaped just a little bit differently. And you can see right here, the groove just isn't deep enough, or not deep as the other ones. And that is what stops the ratchet mechanism from moving forward anymore. And then you can also see the ratcheting there. And what operates those ratchets is not only this little pin on the side, but also our driver pins. And they'll drop into a little chamber every time you turn just a little bit and prevent you from moving the shackle back. So let me give you a close-up of this, and then we will move on to the other lock. Okay, all standard pins, nothing special there. And on the counter mechanism, this brass ring right here is what attaches to these flats on, I guess, the core, what you'd call that. And that's what turns each of these ratchets, which in turn move the counter numbers. Nothing terribly special, and it looks like a relatively cheap mechanism. Okay, let me clean this up, or let me just move this over, and maybe we can put everything from the new lock in chambers 5 through 6. I'm sorry, in the older lock. Okay, we're going to open this one up. I did have it open before. I reset it to 0 just for the novelty of it. But let's see. I guess we'll open it this way to make sure we don't lose any pins. Okay, and right away we can see things are very different in this lock. This lock, all of the bearing components are brass, and it looks like we have some interesting things with the core as well. Let's drop these pins out. Okay, come on. Can't get the... Okay, there we go. Here is our pins from chamber number 1. And right away we can see these are really big pins, and our driver pin in number 1 is serrated. Now in number 2, Slightly smaller pins, but again, serrated. And for number 3, you can see it's being blocked by something, by this little piece of brass here. And actually what that is, let me see if I can pull this out. Rather than having a pin for the ratchet mechanism, this little piece acts as that ratchet. Okay, let's see if we can drop out pin number 3 now. There we go. And again, a serrated driver pin. So big difference between these two locks. Now let's look at the mechanism itself. We can pull off, you can see these all brass components, very nicely made. And to go any further, we're going to have to remove a small pin. Get a pair of pliers here, otherwise none of the wheels will come out. Put that in slot 8, but after that all these wheels come right off, and you can see all of the bearing components. Anything that actually operates and pushes against another piece is made out of brass here, which is a big difference from the all plastic construction on our other lock. And let's see if there's anything else unusual here. Oh, there is one other unusual bit that you can look at right here, and it's not shared with the other lock, and you can see on chamber 2 we actually have counter milling in the core. So another security feature that the newer lock does not have. Okay, let me give you a close-up of all of this. Okay, we have the pins from the older lock in slots 5, 6, and 7. You can see they have all serrated driver pins, and for some reason they decided to make the pin in slot 5 considerably larger in diameter than any of the other pins. Then we get to the counter mechanism, and unlike the newer lock, you can see this entire mechanism, every surface that bears and actually operates is made out of brass here, which is much more impressive than the newer ones. So that's all I have for you on these U.S. Postal Service counter locks. If you have any questions or comments about these, please put them below. If you like this video and would like to see more like it, please subscribe. And as always, have a nice day. Thank you.